Hello students, so today we bring to you an important topic from your logical reasoning section of CAT, that is number series. As the name suggests, this include questions of the form where you have to identify the common pattern among the given number in the series and then predict the missing numbers. Just to cite a very easy example, if you have a series 2, 4, 6, 8, then you can easily predict that the next number in the series over here is 10 because every time the numbers are increasing by 2. Another category of questions that can be asked from this topic is to identify and correct the wrong number in the series. This topic is very important to help you develop your logical and observational skills, which will prove very beneficial to solve other questions of CAT as well. Although from the analysis of previous years, it has been found that specifically CAT does not ask much questions from this topic every year. Whereas other exams like SNAP and XAT, they do ask questions from this topic. So if you are aiming all of these, this topic becomes very important for you. Specifically, CAT does not ask much questions, but as I am telling you, for other exams, this is important. So do not ignore this. Also, taking a benefit of doubt, CAT does something unexpected every time. So let us not take a risk and prepare well for this topic. So without wasting much time, let us discuss that what should be the correct approach for this. See, as the questions asked in this would be very random, it is possible that you may get the pattern at the very first chance and you may not get even after 3 or 4 chances. So you have to keep an open mind as the topic is very subjective. You have to keep an open mind while you are reading a series. You have to try different approaches, which we will be learning in this video after a few minutes. Another thing that will help you a lot is to learn the squares of numbers from 1 to 30. I hope from 1 to 20, everybody must be remembering them because it is very important. But it will ace if you learn it from 1 to 30. Again, you have to learn the cubes of numbers from 1 to 30 as well. So this is something very mandatory if you want to ace the questions of this particular topic, if you want to spend less time and get more number of questions correct. So this is very important. See, till 1 to 20, we learn it from our very, school times. But I would suggest please learn it from 1 to 30. Paste the list on the wall, your notebook, or make it your phone or laptop wallpaper, but do it at any cost because this will help you outshine. So here I have provided you with the list of squares from 1 to 30. Please take a screenshot of this, or you can pause over here and note them down in your notebook. Also, looking at them every day and revising them every day will help you learn it. You won't be able to do it in one single go, but yes, trials and trials, there will be a day when you will be able to memorize them with a click of an eye. Similarly, there are cubes from 1 to 30. These also you have to memorize. You have to repeat the similar process. Either take the screenshot or pause it and note it down. See, when you will write, you will tend to remember it better. So I would suggest please pause it and note it down in your notebook. Okay, so now let us move towards discussing the types of series. This will help you a lot in solving the questions because this will give you a horizon of how to identify the patterns or how you have to keep your approach while solving the questions of number series. So the very first type of series is the pattern in difference or addition factors of consecutive numbers. So this is the most common ones, right? This is the most common pattern that this you have done in your school time also, and you must have seen it in other exams as well. So let us discuss that how do they proceed. Okay, so the pattern over here says 61, 45, 36, 32. So let us find out what is the difference factor. So to reach till 45, you have to subtract 16 from 61. Then similar way from 45 to 36 is -9. Then from 36 to 32 is -4. Now looking at these particular numbers, you see that these numbers are very much familiar to us because they are the squares. So this is the square of 4, this is the square of 3, this is the square of 2. So you can see that the numbers are decreasing. So the next number would be -1 square. So that would be -1. So next number in the series over here will be 31. So you can see that how easy the question was, or Obviously, CAT will not ask such easy pattern, but still it was a good start. Okay, so here is the next question in front of you. As you can see, numbers are very big and they are increasing. They are in an increasing order. So obviously there must be some addition factor. So let us start by a traditional method and find out that what is added to get the next number. So 242 plus 97 will give you 339. In the similar way, 339 plus 89 will give you 428. 428 plus 83 will give you 511. 511 plus 79 will give you 590. So if you look at these numbers 97, 89, 83, 79, at first go you will think that there is no pattern amongst these numbers. But then those who know the prime numbers from 1 to 100 can easily predict that these were prime numbers in decreasing orders. So again, an important thing which you have to learn for your number series is prime numbers from 1 to 100. So please pause it and take a screenshot of this, or please note it down. Better is to note it down with you and write it somewhere. See, till 1 to 50, it is very easy to write down. Anybody can write it down from 1 to 50. You learn it from your very school time. But then from 1 to 100 will help you outshine and identify the patterns easily, which involve the questions of prime numbers. Also, you have to keep one thing over here in mind. There is one in the list is missing. Please remember, one is neither prime nor composite. This you have done from your very junior classes. But just to remind you, one is neither prime nor composite. Okay, so now you can see that these are prime numbers in the decreasing order. So next in the list is 73. So next number would be 590 plus 73. So when you do that, you get 663. So to check the correctness, let us see that what is next number. So next number should be plus 71. So yes, when you do 663 plus 71, you get 734. So our answer is correct. So see how, just remembering prime numbers from 1 to 100 would have helped you to solve this question quickly. Others would have, wasted their time scratching their heads that what the pattern was. Okay. So let's move to the next question, which says 4, 12, 39, 164, and so on. So let us find out, as again, the series is in increasing order. So what is the addition factor? So this is plus 8 over here. So next is plus 27 over here. Then 39 plus 125 will give you 164. Then 164 plus 343 will give you 507. So if you look at these numbers, these are very much familiar to us because they are cubes. Cubes of what? So 8 is 2 cube, then 27 is 3 cube, then it is 5 cube, then 343 is nothing but 7 cube. So over here you can see that numbers are in the addition are in the form of cubes, but cubes of what? That is the question. So many students in excitement, they will think that, they will just look at this 357 and they will do next number as plus 9 cube. But dear students, please look at this carefully. It is 2 cube plus then 3 cube, then 5 cube, then 7 cube. So these are prime numbers in increasing order. So next number will not be 9 cube, rather it will be plus 11 cube. So plus 11 cube will be nothing but plus 1331. That is the cube of 11. So when you solve it, you get 1838 over here. So you can see how easy the question was, but the source of error was that many of us would have ignored this 2 cube over here and thought it as a series of cubes increasing in the order of odd numbers. But these are not odd numbers, these are prime numbers. Okay. So next question is present here in front of you. So over here, if you observe this carefully, you can see that the units place of all the numbers in the series is 2. So let us check the addition factor. So this is plus 10, this is plus 20, this is plus 40, this is plus 60. So I guess, sorry, not plus 60, plus 80. So I guess there is no need to tell. You can see that the addition factor is getting doubled every time. So every time the addition factor is the double of the previous one. So over here, the next number would be plus 160. So when you add 160 to 162, you get 322. That is your correct answer over here. So I hope this was clear and was again very easy. Let us move to the next kind of series over here now, that are multiplicative series. See, addition and difference series, you can see they will be very easy to identify. If you learn the squares and cubes and then the prime numbers, I think you will face no problem in solving the questions involving addition and difference patterns. Next type of series that you will find is multiplicative series, or also you can call this as division pattern type of series. See, what is the difference? If I reverse the multiplicative series, it will become the division series, right? So they are one and the same thing. That is why I have kept them under one single title, that is multiplicative series. Okay, so if you look at the first pattern over here, 5, 7, 11, 37, 143, and so on. See, the first approach that we will keep over here is always difference and addition. But now, how do you identify in exam that the given series is multiplicative? See, it is an indicative in multiplicative series that the first term of the series and the last given term, they have a huge difference, when you subtract them. So it means that the first term and the last terms are very much different from one another in terms of the difference. So over here you can see that the first number is 5 and the last number is 143. So you can see there's a huge difference between first term and the last term. So there is a possibility that this may be a multiplicative series. See, I am emphasizing myself over here. This is only an indicative. This is not a sure shot rule. This is only an indicative that this may be a multiplicative series. So the first approach that we will always follow over here is difference or addition. So you know what we do is plus 2, then plus 4. Okay, so we'll get happy over here that might be some pattern. But when we proceed further, we find that there is no pattern among the addition factors of the consecutive numbers. So let us try our second approach, is to write the numbers in the form of multiplication of the previous number. So if you want to write 7, you can write 7 as 5 into 1 plus 2. If you want to write down 11, you can write down 11 as 7 into 2 minus 3. If you want to write down 37, you can write down 37 as 11 into 3 plus 4. So yes, we can see some pattern over here. See, 1, 2, 3, and then 2, 3, 4, and alternatively plus, minus, plus. So next number, that is 143, should be ideally written as 37 into 4 minus, see, it was plus, so next should be minus. So 2, 3, 4, so next number should be 5. So when you solve this, you get 143 only. So yes, we have cracked the pattern. So you can see the numbers over here are increasing, as natural numbers, and over here also they are increasing, but there is a plus minus sign alternate. So the next number in the series should be 143 into 5. So now it's the turn of plus, so plus 6. So when you solve this particular thing, you get 715 plus 6. That is nothing but 721. So we got our answer. See, now over here also there's a possibility that people may write the numbers in different forms. Like 11 could also be written as 7 into 1 plus 4. But similar way, if you keep on writing, you will identify that there will be no pattern form. So now the only trick over here is hit and trial. So you have to hit and try again and again. It is possible that you get your answer at the very first chance, and it may be possible that you may not get it even, twice or thrice. So keep trying and keep practicing is the only key over here. So the next number present, next series present is 3, 5, 16, 62, 60. So again over here you can see first and the last term. They are very different from one another. There's a huge gap between the first and the last term. So it is an indicative over here that this might be a multiplicative series, right? So first thing that we'll do is let us check it by addition factor. So this will be plus 2, this will be plus 11, plus 44, plus 200. So there's no pattern over here formed. You realize that there's no pattern. So let us pick up our second approach, that is the multiplicative thing. So when we try writing 5, we can write down 5 as 3 into 1 plus 2. Similar way, let's try writing 16. So 16 can be written as 5 into 2 plus 6. Similar way, 60 can be written as 16 into 3 plus 12. Similar way, 260 can be written as 60 into 4 plus 20. Now, when you look over here, we get disappointed because here I can observe a pattern 1, 2, 3, 4, but here I cannot observe a pattern. But now, if you do not give up over here and you try breaking this further, you can write down this as 3 into 1 plus 2 into 1. Similar way, you can write this as 5 into 2 plus 3 into 2. Similar way, you can write this as 16 into 3 plus 4 into 3. So now let's get hopeful because we can see a pattern. 60 into 4 plus 5 into 4. So you can see over here numbers are again increasing 2, 3, 4, 5 into again 1, 2, 3, 4. So if we follow this pattern, the next number in the series should be 260 into 5 plus. So next number over here will be 6 into 5. So that is nothing but 1300 plus 30. So when you solve this, you get 1330. So that is also the correct answer. See, sometimes there might be a pattern inside a pattern. Like over here, when you look at the first, you will see that there's no pattern amongst this, terminating term every time. But when you try to break this further, you find another pattern. So please, that is again the first rule. Keep your mind open while you solve the questions. Okay, so here is the next question present in front of you. It says 3, 9, 32, 167, 1178. So clearly you can see that there is a huge difference between the first term and the last given term. So rather than trying for the traditional method of difference and addition over here, I can clearly predict that it won't work because there's a huge difference between the first and the last term. So it's 95%, or I would say 99% possible that this might be a series involving some sort of multiplicative patterns, because you get such big numbers after multiplication only. So let us not waste time on the traditional approach this time, because it is very clear over here. Let us try doing it with multiplication only. So 9 can be written as 3 into 3 easily. Then similar way, 32 can be written as 9 into 4 minus 3. So, sorry, 9 into 4 minus 4. That is 36 minus 4. Similar way, you can write down 167 as 32 into 5 plus 7. So over here, if I write down plus 0, I can see that there's a pattern over here, 3, 4, 5. So the next number should be into 6. That is 167 into 6. But what here? Here also, if I think that it is alternate plus minus, then what is the next number over here? Because there's no pattern being followed over here. So let us not try with this because I couldn't find out the complete pattern. Let us keep it on hold for a particular time being, and let us try with other approach. Now see, approach over here remains the same. We'll try with the multiplicative thing only, but this was the first hit and trial which I did and did not work. So let us now try writing the numbers in the form of multiplication in some other way. Like, what do I mean to say is, I can write down 9 as 3 into 2, that is 6 plus 3. So that is also one way of writing 9. Similar way, I can write down 32 as 9 into 3, that is 27 plus 5. That is again another way to write down 32. Similar way, I can write down 167 as 32 into 5 plus 7. Similar way, I can write down 1178 as 167 into 7 plus 9. So you can see now that we can see a very beautiful pattern. 2, 3, 5, 7, these are increasing prime numbers. Similar way over here, you can see the terminating term is the addition of odd numbers every time. So if I consider this pattern as correct, the next number in the series should be 1178 into the next prime number after 7 is 11, plus the next odd number over here in the series is plus 11. So when you solve this, you get 12958 plus 11. So again, when you add 11 to this, your answer comes out to be 12969. That is also the correct answer. So over here, you can see at least 3 times we have to make sure that some certain pattern is being followed. If the pattern gets followed for the 3 times, you can surely say that the fourth time and any number of times in the series would be the same pattern. But then in the next video, you will also find some questions where 3 patterns won't be enough to predict the overall pattern of the series. That is again an advanced level, which we will be doing in the next video or video of number series. In this particular video, my motive is to make you familiar with the various approaches and to open your mind for various ideas that you can try while solving a question of number series. If you see any question of number series, there will be various ideas coming into your mind, and in this video my motive is to fill your mind with those ideas so that you do not fall short of ideas while solving the question. That is very important in number series. Also, another thing, while observing these questions, you will find that these particular questions are of very easy pattern. I would say easy to moderate level. Those who are here after 1 or 2 attempts and are preparing for advanced levels will find this video easy. But let me tell you over here, see, our brain is always conditioned to look for the difficult patterns, but sometimes the examiner can trick you by giving easier questions. So at that particular time, we are not able to believe, actually, because our mind is conditioned in that way, we are not able to believe that such simple could also be a question of CAT. So it is very important for each one of us to expose ourselves to every category of question, either it be easy, moderate, or advanced. This opens your horizons while you see the question in the exam. Okay, so let us move to the next question. So 4, 6, 15, 52.5, very simple and very cute small series. So now over here, let me tell you another indicative which will again help you while solving the questions. See, whenever you see a question which contains a fraction or a decimal in it, there are huge chances, there are high chances that it can be a question of fraction multiplication. 95% of the time your question gets solved with this particular approach. So you look for the fraction which is being multiplied to obtain a particular number, and you will find some pattern in the fraction. This happens 95% of the time when you see a series having numbers in decimal form or fraction form. So let us try over here. You can write down 6 as 4 into 3 by 2 easily. So I'm not using any difference approach over here because I have told you a sure short indicative over here that 95% of the time it is possible that it is fraction multiplication. So let us first aim for the higher probability. So 6 can be written as 4 into 3 by 2 easily. Similar way, 15 can be written as 6 into 5 by 2 easily. And 52.5 can be written as 15 into 7 by 2. So you can see a beautiful pattern over here. In the numerator, the numbers are odd, and in the denominator, the number remains 2 every time. So the next number that is missing in the series should be nothing but 52.5 into the next odd number is 9 upon 2. So when you solve this particular thing, your answer comes out to be 236.25. So that is also the correct answer. And I'm hoping over here that each one of you is solving along with me and has opened the on-screen calculator in the other tab. I am hoping by now you have, a habit of using this calculator, because this is the game changer. This is very, very important. If you are not into the habit, please start using this calculator while your practice sessions only, because in exam it will become very difficult to become handy with it in a one go. Okay. So now let us move to the other type of questions that can involve questions of Fibonacci sequence. See, this is very easy approach. This is very easy approach. And I should say that this should be your first approach once you have tried your difference and addition and you cannot find something, good, then this should be the next approach before the multiplication thing, because this is something, trending nowadays in exams, and students, they often ignore this kind of sequence. So let us first understand that what is a Fibonacci sequence. So in Fibonacci sequence, the next number is nothing but the addition of the previous two numbers. So like over here, you can see 2 can be written as 1 plus 1. Similar way, 3 can be written as 1 plus 2. 5 can be written as 2 plus 3. 8 can be written as 3 plus 5. So you can see every time the numbers are getting added to give you the next number. So this sort of series is a traditional Fibonacci sequence, but there can be variations in this. So let us understand by certain examples that what can be variations. So now when you look at this particular question, our first approach would be addition or subtraction, right? So when you do that, you will find that there's nothing useful coming out. So if you observe carefully, 43 can be written as 17 plus 26. Similar way, 69 can be written as 26 plus 43. 112 can be written as 43 plus 69. 181 can be written as 69 plus 112. So the next number in the series should be nothing but 112 plus 181. So when you solve this, the next number comes out to be 293. So you can see that how easily, without using a paper or a pen, you can predict the answer in this particular type of sequence. But the only thing is that it should strike your mind that this can also be a possibility. Rather, I would say that even before trying difference or addition, if you try for Fibonacci, there may be high chance that you may get your answer in the very first time. Okay, so this was a traditional type of Fibonacci sequence. Let's move to the next one. So over here again, let me tell you an indicative. Whenever you see repetitive numbers, there are chances. Number one, it could be a Fibonacci sequence. That is the very first possibility. And the second possibility could be fraction multiplication again. So this again, I'm giving you an indicative. This is not something sure over here. This is again an indicative. The first thing, whenever you see repeated numbers in any series, is that you try for Fibonacci. And if not, then you try for fraction multiplication. Okay, so let us try for Fibonacci over here. So when you look at this, 1 plus 1 is not giving you 3, rather it is 2. But 2 is present over here. So let me go ahead. Maybe I can get something useful. So 1 plus 1 over here gives you 2, which is not the very next number, but the number next to the next one. Now over here, you can see 1 plus 3 is 4, which is present over here. So it is again a Fibonacci sequence, but of a different form. Now 3 plus 2 again over here is 5, which is present here. 2 plus 4 is 6, which is present over here. So you can see it is not a direct or a traditional Fibonacci, but something different. So the next number after 6 would be nothing but 4 plus 5, that is 9. So you can see at the very first go, we may quit thinking that this is not Fibonacci because here it is not 2. But then again, I told you there can be variations. There are high chances that it may not be a traditional Fibonacci. Rather, there can be, variation in the series. So you have to look for that particular variation. Okay, so here is the next question present in front of you, which is 11, 13, 17, 25, 32, 37, 47. So you can see that the numbers are increasing continuously, and then there's no huge difference between the first and the last. So obviously it can't be multiplicative. So the next approach, or I would say the first approach, ideally should be the addition factor over here. So when you do for that, it is plus 2, then 13 plus 4 will give you 17. Then 17 plus 8 will give you 25. Then 25 plus 7 gives you 32. Then 32 plus 5 gives you 37. Then 37 plus 10 gives you 47. Now, when you look at these numbers, you will think that there is no pattern. But students, let me tell you that this is a good question. And if you have solved it right, then you should be proud of yourself because this is a PYQ of your SNAP exam. So this was a PYQ of the SNAP exam. Now, this question is under the category of Fibonacci as we are discussing that. So that would be your next approach. Many of you might have tried Fibonacci by this time. But still, I challenge you to solve this question by pausing it and trying it on your own because this question is not just Fibonacci. It involves the concept of Fibonacci plus sum of digits. This is the favorite concept nowadays of the examiners who set competitive exams. So in this particular series, you can see there's no particular pattern in the addition factor. And then it is also not Fibonacci because clearly 11 plus 13 is not 17. Numbers are close with one another. They are not so, different from one another. So then it is also not alone Fibonacci, but this is some sort of Fibonacci which also involves the concept of sum of digits. Now, what do I mean to say is if you observe these digits carefully, which are added every time, these are nothing but the sum of digits of the previous number. Like this is plus 2 and 1 plus 1 is also 2. Similar way, 17 is arrived at by adding 4 to 13 and 13 is also but 1 plus 3, that is 4. Similar way, 17, 1 plus 7 is 8. So next number is plus 8. 2 plus 5 is 7. So next number is plus 7. 3 plus 2 is 5. So next number is again plus 5. Similar way, 3 plus 7 is 10. So next number is plus 10. So what according to you should be the next number is very clear. So 4 plus 7 is nothing but 11. So 4 plus 7 is 11. So next number should be plus 11. So when you add 11, you get 58. So the next number in the series is 58. So this was a tricky question. You can see it was so simple, less than 30 seconds. This question took less than 30 seconds and you could solve it orally without a paper or a pen. But then again over here, you would have tried everything, addition, subtraction, division, multiplication, Fibonacci, but still you would have not have arrived at your answer. But then again, if you look at these numbers carefully, the game of numbers in this, you will arrive at the conclusion that the number that is being added every time is nothing but the sum of the digits of the previous number. So this is a kind of tricky question that can be formed in the exam. If the examiner wants to make the paper a little towards difficult side but less lengthy, he or she will surely choose a question from this particular concept. So this should also be in your mind. See, dear students, now I have told you about the basic type of series that can appear in front of you. They can be addition, subtraction, multiplication, division, Fibonacci, and then Fibonacci plus sum of digits or only sum of digits. Now, the motive over here was to give you to give you a view that how you can solve a question, to open in front of you different horizons, to open in front of you plethora of ways to solve the questions. So now it only depends upon practice. See, there is a sea of resources. There is a sea of resources for this particular topic. Whichever book you are following, Arun Sharma, R.S. Agarwal, any book or any internet source or any coaching institute notes, you will find that there are infinite questions of number series. Please keep on practicing them time to time. This was what could be the basic till now. And then based on this, only advanced questions are formed. There can be questions involving number of concepts that we have studied till now. So I hope the basic type of series are clear to you. Now you have to practice as much as you can. So now let's move to the next type of series, that is squares and cube series. This is indeed a difficult one. A difficult question can be framed out of these. So the best way is to crack is that you have to learn these. Now again, one more thing to learn. Special types of series, squares and cube series. They involved arithmetics of squares and cubes. Cube plus number, cube minus number, cube plus square, cube minus square. So these are the four basic types: n cube plus n cube minus n cube plus n square. n cube minus n square. So now what is the purpose of this? See, when this kind of series come in exam, it takes a lot of time to arrive at the pattern. It takes a lot of time to strike such kind of pattern. So my motive of telling you to learn is that you become familiar with numbers like these. So that when you see numbers like these, you can quickly identify that, okay, if it is not addition, if it is not division, if it is not subtraction, if it is not multiplication, if it is not Fibonacci, then it can be something of this form. And sometimes even in differences of two consecutive numbers, this kind of pattern may be there. So, again, pattern in pattern. Sometimes, you have done everything of the world around you, but then also you are not able to identify. If you look at the difference or the addition factor, that may be of this particular form. So this is something that students or aspirants, they tend to ignore. But then there's a difficult question that can be framed out of it. It is actually not difficult. It becomes difficult because we are not into the practice of thinking that this could also be possible, right? So over here n is 0, 1, 2, 3, 4 and 5 and so on. So let's try to frame the first kind of series n cube plus n. So in the first case, we'll keep n is equal to 0. So 0 for 1, it will be 1 plus 1, 2. For 2, this will become 8 plus 2, that is 10. For 3, it will become 27 plus 3, that is 30. For 4, it will become 64 plus 4, 68. So for 5, it will become 125 plus 5, that is 130. For 6, it will become 216 plus 6, so triple two, and so on. So I would recommend, please learn till n is equal to 6, so that whenever you see a series like this, you can quickly identify that this may be the pattern. So generally we try to find pattern between two numbers, and then we realize that, okay, over here the independent number had a pattern, common pattern. So independent number is having a common pattern, but there is no pattern, there is no connection between the two numbers. So this kind of question is also possible. And generally in series, we do not think like this. We always try to find the pattern between two consecutive numbers. So it is very important to learn to identify such kind of numbers, so that when they appear in front of you, you can guess that it is it. And also, if examiner wants to make the question a little difficult, it is possible that the examiner may not take the series starting from n is equal to 0. Maybe the series starts from n is equal to 4 and goes on till n is equal to 9. So over here, so now it is, so there are number of permutations and combinations possible. N can be anything, and that is also true that as aspirants you cannot learn all the permutations and combinations. But the motive of learning the basic one is that it gets fit into your brain. So what are we doing over here? We are tuning our brain to identify such numbers. So that tuning will come if you learn the basic one, then it will be set in your mind. It will be somewhere in your subconscious mind that, okay, let me try this. It may be possible, right? And if you are fortunate, you may get your answer in the very first chance itself. Okay. So now let's go into the next type of series, n cube minus n. So n cube minus n, if you keep n is equal to 0, so 0, 1, again 0. So, see special type of pattern, 0, comma 0. So many a times we may get confused looking why 0 two times, right? Next is 2. So 2 is 8 minus 2, that is 6. When you put n is equal to 3, so 27 minus 3, so that will be 24. N is equal to 4, so that will be 64 minus 4, that is 60. N is equal to 5, 125 minus 5, 120. N is equal to 6, 216 minus 6, so that is 210, and so on. So again, please try to remember this series from n is equal to 0 to n is equal to 6. So let's move to the next type of series, that is n cube plus n square. So series of the form n cube plus n square. So if we put n is equal to 0, we get 0. If we put n is equal to 1, so 1 plus 1, 2. N is equal to 2, so 2 cube is 8, plus 2 square is 4, so 12. Then we put n is equal to 3. So 27 plus 9, that will be 36. Then n is equal to 4, 64. So 64 plus 16 will be 80. Then n is equal to 5. So 125 plus 25, again 150. N is equal to 6. So 216 plus 36 will be 252. So 252. So on. This series also goes on till you can learn it till n is equal to 6, but it goes on till infinity, right? Okay. So now next series is of the form n cube minus n square. So for n is equal to 0, 0. For n is equal to 1, again 0. N is equal to 2 will be 8 minus 4, that is 4. N is equal to 3 will be 27. 27 minus 9. So 27 minus 9, will be 18. The next will be 64 minus 16. So when you do 64 minus 16, you get 48. Then will be 125 minus 25. So that is 100. Then 216 minus 36 will be 180. So on. So again, please learn this series till n is equal to 6. Now basic motive over here is that you try to identify, especially if you see double zero, if you see double zero, then you can directly check for n cube minus n or n cube minus n square. Fine. So this type of series, this may be a direct series or maybe a pattern present in difference or multiplication. So please check for such patterns as well. Please learn them. Please note them down somewhere. Pause the video and please note them down somewhere. So with this, we have discussed all the types of series that are possible. And in coming videos, we will be practicing questions based on series. So this was a very, very important lecture. I hope you all have noted down the squares from 1 to 30 and cubes from 1 to 30. And from today onwards, please start learning them so that till your exam time, they are on your tips. Goodbye until next. So now that you have understood the topic through our videos, I would recommend you to try the practice tests of the topic number series available on our EduRev app. Apart from the tests, we also provide a full fledged course to support you in acing your CAT preparation through 170 plus interactive videos and video lectures, 150 plus comprehensible documents, and 110 plus tests comprising topic wise, section wise, and 20 plus full length mock tests. So keep on doing your rock solid preparation and quickly go and check it out on our app.